Hello, POA students. Utility bills part 1 video. Number 1, make sure you put your Gmail address in there. A little bit from the reading. Power is the rate something uses or produces energy, and watts is the units for power, one of the units, the most common units, and that is referring to a watt is 1 joule per second. Okay, sometimes you'll see it abbreviated at J over S. It's also 1 volt times 1 amp, okay, or 1/746th of a horsepower. So there are 746 watts in 1 horsepower. Sometimes you'll see power referred to in LEDs, and some of the other an LED uses 0.15 watts. Some of the other prefixes that we use commonly, 1,000 watts is called a kilowatt. That would be 10 to the third. 1,000,000 watts is called a megawatt, and that will be a capital MW. Okay, so that's a megawatt. That's for using extremely large amounts of electricity. Okay. And another term that we'll be using quite a bit, electric bills are based on how many kilowatt hours are being used. Okay, so a kilowatt hour is enough energy to supply 1 kilowatt of power for 1 hour, and it's basically a kilowatt times an hour. So let's take a look at some of these questions. What does power describe? This is the first thing that we mentioned up here. Power is how fast energy is being used or how fast the energy is being produced, either way. Number 2, what is the formula for power? Power equals work divided by time. Okay. What is the unit for power? Watts. Number 5, how many joules of energy would it take to run a 100 watt light bulb for 10 seconds? So when we look at this, we're going to be using this equation quite a bit here. Power equals the work or joules divided by time. Joules per second. Okay. So in this problem here, how many joules we're looking for, we're going to be looking for this right here. So we need to put the information in that we know and then solve for what we don't know. We know that it's a 100 watt light bulb and we know it's operating for 10 seconds. So the 100 watts is our power equals the joules we don't know. We'll just make that an X divided by 10 seconds. To solve for this right here, okay, whatever's math is being done, we need to do the opposite, and we do it on both sides. So this is, we're dividing by 10 seconds, so we're going to multiply by 10 seconds. That will eliminate this over here, cancel out, but then also we need to multiply this by 10 seconds, and it gets a little bit messy here, sorry about that, but let's just get rid of this, okay. So we can see it's 10 seconds times 100 watts. And by the way, we could replace watts here with what a watt is a joule per second. And that will let you see that seconds cancel out on this side, and we're left with the units we're looking for, which is joules of energy. 10 times 100 is 1,000 joules. Okay. Let's see. Number 6, how many joules of energy would it take to run a 100 watt light bulb for 2 minutes? Okay, so again, power equals joules per second. Watts equal joules per second. In this case, we're given the time in minutes. We're given the watts. We're looking for joules. So again, we've got 100 joules per second, or watts, equals X. We're looking for the joules. In this case, it's 2 minutes. So for every minute, we have to convert that to seconds, because on the bottom it's joules per second, not joules per minute. So there's 60 seconds per minute times 2 minutes is 120 seconds. 20. So that would go down here, 120 seconds. Okay. And then we just have to solve for x, or joules. And again, we're going to multiply by 120 seconds on both sides. Seconds cancel out here. Seconds cancel out here. 120 divided by 120 is 1. So we have on this side, we have 120 times 100. Will give us 12,000. 12,000 joules. Okay. How many joules? Again, how many joules of energy would it take to run a 100 watt light bulb for 1 hour? So you notice in each one of these problems here, the problem's exactly the same. It's just the time is changing. 10 seconds, 2 minutes, 1 hour. And remember, our power is joules per second. So all it's making us do is change our time into seconds. Okay, so in 1 hour there are 60 minutes. So if we could do this conversion here, we'll say 1 hour. Okay, we can do a conversion. For every 1 hour there are 60 minutes, and that will cancel hours, top and bottom. But we don't want minutes, we want seconds. So for every 1 minute, there are 60 seconds. And that will cancel minutes, top and bottom. So what are we left with? 1 times 60 times 60 is, we've got our units here, 3,600 seconds in 1 hour. Okay. Excuse me. So let's set up our problem here. Power equals joules per second. Our power is, again, it's 100 watts. Equals joules per 3,600 seconds. You can get rid of 3,600 seconds, but we have to do it on both sides. So we end up with 3,600 times 100. Okay, 3,600 times 100 is going to keep the same number of zeros, and just add the zeros from the 100, and we get 360,000. Okay, 360,000 joules. Okay, number 8. How many joules of energy would it take to run a 1,000 watt light bulb for 1 hour? Again, this is the same question. How many joules? You've got a 1,000 watt light bulb for 1 hour. So we already converted 1 hour, okay, to seconds up here, and it's 1,000 watt. You guys can do that question. Okay, a kilowatt, take a look up here. A kilowatt is, kilo is right here. And number 10, how many joules would it take to run a 1 kilowatt electric heater for 1 hour? Okay, a 1 kilowatt electric heater for 1 hour. Well, again, a kilowatt is right. We just talked about it. 1,000 watts. A kilowatt is 1,000 watts. 1 hour is the same amount of time. It's going to be the same thing that you had here. Okay, and how many joules are in 1 kilowatt hour? Again, it's the same question. Is 1 kilowatt times 1 hour. It's going to give you the same answer for this one as well. So I'm going to let you do a few of these yourself, And good luck on these questions. Email me if you have questions.